Hi, so what I want to talk about right now is I want to go over some tips that I think can help you to become a better math student. This is primarily aimed at, I would say, like pre-calculus, calculus students and above, although it could easily be helpful to students that are in a lower level class and students that are a little bit higher than that. But it's primarily aimed at that level, kind of the transition that a lot of students make at that level, because there is a big difference between, um, say, high school classes like algebra, geometry, and then when you start getting into the STEM sequence with pre-calculus, calculus, differential equations, linear algebra. So what I really want to lay out here are some steps that I think students can take to succeed more in these types of math classes and just become a better student overall. A lot of these ideas, of course, I've gotten from my own experience as a student for many years when I was in undergraduate and graduate school, but also in teaching and observing students that I've had and I've observed some of the habits of better students to be. So there's five main things I'm going to go over, and I think like a lot of people, none of these I don't think are original to me, but I want to kind of add my own touch to all of them. So let's start with the first. So the first main thing I want to get across is that one of the big differences, and this is a kind of a big difference between high school math and college level math, is you really need to take a more proactive approach to your learning. So what do I mean by this? Take ownership of the learning process. When you're in high school, I think it's very easy to think that, you know, I go to class, we do most of our work in class. You know, I get some feedback from the teacher. I have, you know, multiple opportunities to take exams and quizzes. If I'm getting off track, someone's probably going to let me know. So in that case, you know, a lot of the learning process being driven by the teacher or by the school. And in college, you really have to take flip that around. You have to take that you're the primary person who's going to be taking ownership of the learning process, and let that drive a lot of the decisions that you make. So you have to keep up on how you're doing. You have to keep up on, you know, reflecting on where you are. So that's the first main point. And you really have to have a change of view of the instructor. When you're in high school classes, I think a lot of students see the instructor as kind of a source or transmitter of knowledge. You know, if you ask a lot of students, you know, what's the purpose of the instructor? What are they there for? And they'll say, well, they're there to tell you what to do. They're there to tell you how to do the problems. And yes, that is true, but I mean, the real purpose of an instructor or professor should be to facilitate your own learning. In other words, they should be able to give you a background on a certain topic. They should be able to give you good examples. They should be able to kind of get you the feel for the 30,000 foot level of what's going on. If you're stuck, they can help you get unstuck. They can help you with problems you're having, problems with homework and things like that. But you have to be the instigator of your learning and not rely on the instructor or the professor to be the beginning of that. They're guiding you along. So some more specific examples of this. You can read ahead in the textbook before class. Review your notes afterwards. Think about your notes right after class. Look at them and see, you know, what did we go over? Can I fill them out, flesh them out some more? Spiral back to previous topics. So as you're going through the semester, when you're a few weeks in, go back and look at stuff from a few weeks before. Math is cumulative, so you need to constantly be going back and looking over old topics and old problems. Ask questions about anything that you don't understand. Go to office hours. You know, think about what you need to work on, and then find those areas and work on them. So take a proactive approach to your learning. Next major point I'd make, and this is really important, I think. understand that struggle and failure are normal parts of the learning process. This is something I think a lot of students don't really understand. Realize you're not going to be able to immediately grasp most ideas at first, especially, and this is, say, at the calculus level and beyond. Ideas are not going to come the first day that you see them in class. They're not going to come a few days afterwards. They might not come for a week or two afterwards. Sometimes the ideas might not come for a month more. Now, I understand that there is there's a certain pressure in that you're going to be having exams coming up. You're going to have an exam in a few weeks. You're going to be having an exam in a month and a half. And you do need to prepare yourself for the exam as much as possible and make sure that you do everything you can to do well on it. But there's a difference between preparing for the exam and thinking that you're really internalizing these ideas. That true internalization and understanding and comprehension, where you really think, I really got this. Now I get what he was saying. You have to understand that might not come until the next semester. I mean, this happened for me when I was an undergraduate. I was taking calculus, and then, maybe a couple semesters later when I was taking multivariable calculus, it's like, now I really get the fundamental theorem of calculus. There was some classes that I took, like the first time I took abstract algebra, I was good at doing all the definitions. I could recall them. I could, spit out all the proofs. I could do new problems and new proofs. But I remember it took like a semester or two. It took a semester or two when I went back and I finally thought, now I understand, why this definition has to be the way it is. So these are long-term, your learning process is a very long-term process. It's not something that's going to come about in the short term. And we understand that you have to be thinking about the homework and the exams, but don't let that get you to lose sight of that fact. Another big point, embrace confusion. So what I mean by this is a lot of students, I think, when they struggle with a topic or they can't get a homework problem or they don't understand their notes, they think that that's a sign that something's wrong. In other words, they think, this means that I'm dumb or I'm just not good at math. That's not what it means. If you're confused about something, it could mean a couple things. So if you're confused about something, one thing it could mean is that you might not have had the adequate preparation to understand the topic. So that is something that you might need to look at. So think about what are the necessary skills that you have to have beforehand. So like if you're in a calculus class, you need to understand all of the algebra and trig topics. So setting that aside, if you're confused about something, that means that you're engaging with the material. There's no topic that somebody learns in math without going through this process of confusion. Even so, people who are really, say they're naturally talented at math, they still go through this process. It might be quicker. It might not last as long, and they might get through it with less pain, but they still go through it. I mean, I remember when I was taking classes, when I was taking upper division classes, again, I would look at the definitions, I could kind of go through them, but I didn't quite get, what is the point of this? Why is it exactly this way? And I would struggle with it. And that confusion, just understand that that's a normal part of the learning process. It's a constant part of the learning process. If you're thinking when you're confused that something's wrong, I'm doing something wrong, this is not what's supposed to happen, understand that's not true. You're supposed to struggle. You're supposed to confuse. What makes a difference is what you do with that confusion and that struggle. Treat each failure as a learning opportunity. And I know this can be difficult, especially if those failures happen to happen on exams. But there's little failures that you happen. You work on a homework problem. The first thing you try doesn't work. You're working on the homework. You put in the answer. It marks it wrong. Instead of looking at that as, this means I didn't get the points here, or I wasn't able to get this. Look at that as a learning opportunity. Every failure is telling you something that it's an identification of something you need to work on. And remember, if math were easy, everyone would be able to do it. There's a reason, there's a reason that that everyone is not able to do math, and that's because it takes a lot of time, it takes a lot of practice, and it takes a lot of struggle. And a lot of people are just not willing to do that. They meet the time they understand the amount of time that it takes, the practice that it takes, and they say, I'm just not willing to do that. So if you want to do well in math, a large part of it is just being able to tell yourself, I'm willing to put in the time, I'm willing to put in the struggle, and I'm willing to practice different problems over and over again. Third point. So this has to do with just an approach to thinking about math. Treat your learning in math as play, not as a mechanical memorization of techniques and problems. And this isn't something. It's something you can tell somebody, but you almost have to have it in yourself to begin with. If you have to have an intrinsic feeling that math is fun, that problem solving is fun, and that's something I can't really impart to anybody if you don't already have it. But if you look at your learning this way, it will really help. So some specific things about what I mean about this. Focus on questions as much as answers. So what I mean by this is, say you're in first semester calculus class. When you're studying derivatives, always think back to, why are we learning this technique? What was the whole point of why we're studying derivatives in the first place? What were the original problems? Why were people thinking about this at first? Every problem, every subject in math arose out of questions. So try and keep in mind, what were those questions that people were thinking about? Make up your own problems and examples. After you study something, just play around and think, well, what if I can make up my own example and see, what comes from this? Maybe nothing comes from it. Maybe, you discover something. Whatever happens, that's fine. Discover the intention behind definitions and rules. So really try and get behind why are things the way they are. The definitions, the rules that mathematicians make up, they're not done arbitrarily. There's a meaning behind them. There's an intention behind them. Like the definition of the derivative, that there's a reason it is the way it is. It's not just something that you should memorize. Try and figure out why things are made the way they are. Change your assumptions. Consider what effect that has. So if you're studying a certain theorem or certain result in pre-calculus or calculus, change one of the hypotheses and think, well, why do I need this? This is part of the, like for the intermediate value theorem or the mean value theorem. Think, well, what if we didn't have continuity? What if we didn't have this? Why would it go wrong? So if you're constantly playing around with examples like that or results, saying, well, what if I change this a little bit, how does that affect what's going on? Then by exploring what happens in that case, you'll come to understand the original result better. Try more challenging, open-ended questions. So don't be afraid to, try. A lot of books have these review sections and they have challenge questions in the back. Take a look at some of those sometime. The worst that could happen is, you look at some of them, you think about them for a while, you try them, you don't get anywhere, that's fine. Some of them you might get some starts and, get a little bit into it and not finish them, that's fine too. The point with stretching yourself by looking at more challenging problems is not to get the answer. The point of it is to practice your problem-solving skills. And the more challenging problems that you try, even if you don't get them, the better you'll get at problem-solving in general. Okay, fourth, let's talk about studying a little bit. So studying intentionally. So first of all, study in an environment that's free of distraction. Study in an environment that cues you to study. Don't study in front of the TV. Don't study with your phone next to you. That's your texts and Facebook notifications are going to come up all the time. So this is very, very important, to study in an environment that cues you into studying, and that is the similar type of environment every time. Have clearly defined goals for every study session. So I think a lot of students will sit down, they say, well, I'm going to study. Okay, that's fine. So you study, and you don't really have an idea what you're going to be doing when you're studying. So they just kind of randomly open notes and randomly read stuff, and just open homework assignments and just go through them, just doing what they can, and then not having any clearly defined idea of what to do when they get stuck and so on. So when you're sitting down, think about, what's my goal for this session? Okay, so just to give you some examples, maybe when I'm sitting down, I'm going to work on a homework assignment. Okay, so I'm going to work through as many problems, get as far as I can through them. At the end of that, then I'm going to identify what I wasn't able to do. I'm going to make a note of that so that the next time I sit down in the next session, I have a list of things that I can go and look up. Or maybe I'm doing a study session where I'm preparing for an exam and I'm making some flashcards. Maybe there's a study session where I'm reviewing my notes and I'm really intentionally reflecting over what was covered previously in class. Maybe I'm sitting down and the purpose of the study session is to read ahead a little bit, to skim ahead, even if I don't get everything, just get a sense of where we're going to be going the next week in class. So there's a lot of different things you can do when you study, and you need to have a sense of what you plan on doing when you sit down. Don't just sit down and study and just randomly just start doing stuff. Develop a plan to identify and improve your weaknesses. So this is something that people who are experts or highly skilled in different areas are very good at. They're able to identify their weaknesses and really focus in on those weaknesses. So that's where they spend their time. If you're not identifying your weaknesses, you're being very inefficient in your use of time because you're spending a lot of time on stuff you already know, and your knowledge, your skills, your abilities are really as strong as your weakest link. So if you can identify those weak links and work on them, that's really going to help you. Take time to reflect on your learning and progress. So think back. If you were able to get a problem, why did it work? What did I do? What worked out well? If you weren't able to get it, why did I stumble? Why did I get stuck on it? Take time to think about, how you think you've grown in your learning over, in the mid-semester. Think about, well, what do I know now that I didn't know? What am I still confused about? So kind of step back a few feet and think about, just not every day, but from time to time, think about what's going on. Another thing about studying, I didn't mention it here, this is especially true in mathematics. One thing that's really true about mathematics is repetition. So for instance, say you're in a calculus class and you need to be able to take derivatives. You have to take a lot of derivatives. You have to do a lot of problems. A lot of math is just doing a lot of problems over and over and over and over again. But you have to do it in the right way, right? We have to do it in the way of identifying your weaknesses. So not just doing them and then just, randomly doing them without any plan. Doing them, going through some, identifying your weaknesses, working on those, going and doing some, doing more again, practicing more again, then taking time to reflect on what you're doing, asking questions about things you don't understand, and then doing them again. So it's repetition, but with a purpose. Think of it like if you're a basketball player, or you're trying to learn a video game. So everybody knows if you're a basketball player, even the best basketball players are constantly practicing shooting free throws. I mean, because it's a skill that you're going to lose if you don't use it. And it's just repetition. If you're playing a video game, you know that you're not going to get to the highest level unless you repeatedly work through the previous levels until you got them down cold. And it's the same thing with math. Okay, the last part here, I wanted to go over a little bit about exam preparation. So a number of things you can do. People are always asking, how can I get ready for exams? So one thing you can do, I did this a lot when I was an undergraduate and also graduate student. You can use flashcards to remember important definitions, notations, examples, proofs. and not just right before an exam, but do them. You can develop these or make them throughout the semester, and then you have them ready before the exam. So I remember one of the first classes I took that really stretched me at first was a linear algebra class. This is usually taken after calculus. And one thing I quickly noticed after about 2 or 3 weeks was there's just a ton of definitions and notations. And I was just having trouble keeping track of them all in my mind. So I just started making some flashcards, and I would just write, like on one flashcard, I'd write, the definition of linear independence. On another flashcard, I'd write, the definition of, basis. And there were so many definitions and theorems like this. And eventually, by the end of the semester, I had like a set of flashcards, about 200 or 300 flashcards. And then as getting ready for the final exam, I would just, shuffle them up, pull some out. And what I would do is I would have a definition, on one side and then the answer on the other, or, an example or something on one side and then the answer on the other. So if it's a definition, I would say, spanning set. And then on the reverse side, I'd have the definition of the spanning set on there. So you look at the first side and you see, can I remember it? If you do, great. If not, then you can look at the back and then recall it. Same thing with statements of theorems or different examples. Go back and review your notes, previous homework problems, again, especially things that you think you haven't mastered. Okay, this next one is super important. This is something that I really used when I was a student to get ready. Take a mock exam beforehand that mimics the exam conditions. Now, if you have a review sheet, that's great. You can get problems from the review sheet, but a lot of classes that I took, even an undergraduate, this was many years ago, but a lot of classes I took that the professors didn't give us a review sheet with problems, say. So I would have to come up with problems on my own. There's places to get these. You can go back over homework problems, change the numbers a little bit. Most books each chapter has a set of review questions at the end. You can do that. You can just do a Google search, look online for problems, but get a set of questions. So here's very specifically what you can do. Get a list of questions that is going to be representative of what's going to be on an exam. Do this one day, and then put it away. And so get the questions, and then the answers for them as well. Put them away. Do it a day or two later, so that your mind doesn't have the answers fresh in your memory. If you go and you just look at a bunch of questions that you've gathered, and then you immediately take it like it's a mock exam, that's not going to work, because you're going to have those questions are going to be fresh in your mind, because usually when you find them online or you look them in a review sheet, the answers might be there. You've had a chance to think about them. So what you want to do is make out this mock exam, come back later, a day or two later, when you're looking at it kind of fresh, and look at these problems. This is the important part. Look at these problems without your book, without your notes, as if you were in an exam. Now, what's usually happens then is you're not going to get all of the problems. That's fine. What that means is now you know what to work on. You know what you really know. See, this is the point. You don't really know what you really know until you've put yourself into this situation. Another way to put it is, you don't want the exam to be the first time that you try a problem without resources. When you have a problem that you see in exam, you should be been there, done that. You should know, I've already seen this problem 3 times, or done it 3 times already without my notes, without the book. And there's two reasons this is good. First of all, it solidifies that you really know the topic. And the second really important thing is that when you take these mock exams and you're able to do the problem without the books or without the notes, that gives you a tremendous confidence boost going into the exam, because essentially you're going into the exam knowing that you're certain that you're going to do well ahead of time. And that makes a real big difference. If you're going into exam and you've kind of been studying where you're relying on your notes, you're relying on the book, you're relying on looking back at what the teacher has done every step, then when you get into the exam, You don't have that confidence because you're like, well, I've kind of copied what's been done before, but am I really able to do it on my own? If you've done this kind of mock exam where you're trying stuff on your own, then going in, you're like, yeah, I know all these types of problems that are going to show up. I've done them before. I know that I can do them before, and it'll really increase your confidence. Don't waste time on topics or problems you've already mastered. So this is just using your time efficiently. And then the last couple of things, not really academically related, but I found are really important. Get a full night's sleep the night before. Okay. You don't want to take an exam on without getting enough sleep. You can study all semester. You can be completely prepared. And if you don't cram the night before. If you cram the night before and you're up until 3 a.m. and you get 3 hours sleep or something, it can erase all the work that you've done before. So it's very important to get sleep the night before. And also, nutrition the day or two before the exam. Make sure you got a full stomach. So getting a full night's sleep and a full stomach actually is very important. Make sure you've had enough protein. Don't drink alcohol. Stay away from sugar and processed foods before the exam, and drink a lot of water. Stay hydrated. You really have to approach exams almost like a sport, because they are. Even though it's like a mental sport, you have to approach them like it's a physical sport, like you were, in track and field or baseball or something. Because it is your ability to perform mental tasks is not independent of your physical condition. If you're rested, if you have a full stomach, if you're hydrated, you've drinking water, you haven't been eating crappy food the day or two before, your body is just going to be better able to perform, even if it's a mental task instead of a physical task. It's the same reasoning applies. You wouldn't want to go into, if you were an athlete, you wouldn't go into the important game the next day, staying up all night, partying the night before, and, not eating a bunch of crap beforehand, and, not drinking water and stuff. You know that in that case that you should be physically prepared for a sport. You have to take the same approach towards exams. Okay, so I hope this was helpful. So I think this is, again, a lot of these things I think are covered. None of these are original to me, but I think hopefully by organizing them all and putting them in a single video here, that this is giving people a lot of ideas on specific concrete things that you can do to do better in your math classes. So good luck. I'll talk to you later.